Okay, welcome. So today we'll be talking about, like, this is, if you remember, we had this schedule here. So today we will be talking about the first lecture on technical foundations. Two topics, version control and HTML, CSS, selectors, and so on, everything that you need to know for homework 1. We'll continue then next week with JavaScript basics. And it's like, how do we interactively manipulate the DOM, and so on. And then, starting next Thursday, we will actually get into D3 for the first time. So D3 is this language that we will be using for homeworks, the data-driven documents, where it's really about how can we bind data to elements in the DOM and make those DOMs look like something nice and therefore do visualization. And so, like, this will continue until until week 4, where we will essentially move away from the purely technical details. So this today is going to be like a little bit like a tutorial. You're actually encouraged, as I mentioned last time, I suggest that you don't use your devices, but today is actually a coding session. So everything that I'll be talking about is, like, you can go, like, look at the tutorials here, and if you go here, this is what we'll go through today. So the HTML lecture, we'll start with this, and then we will do version control with Git. Any questions about the organization of the course or anything else that you want to ask? Okay. And so, by the way, feel free to interrupt, to ask questions. Like, I really would like this to be as interactive as possible. So, who knows who thinks they know a bit about DOM and HTML? Just so I get an idea. Okay, I hope I'm not going to bore you too much, guys, but I also want to, like, give us the foundation so everybody knows what we're talking about. So HTML is traditional, like, it's the name of HTML is Hypertext Markup Language, and it actually has an anniversary in the last couple of days. Tim Berners-Lee developed it at CERN, and well, at least the web, and so we've been using it ever since to present documents on the web. What has changed, however, is what we can do with it. Like, if you think back to the middle of 2000s, websites were mainly like presentations, documents, and so on. And nowadays we can build applications on the web. So we can do things like what used to be Microsoft Word on your computer that you have to install. We can now do documents. So it has transitioned from this document presentation platform to this really platform for building web applications. Showever, it still isn't really like at the level of where desktop software frameworks are. So if you say want to develop something in C++ and Qt or Java, you will have much more support of developing sophisticated applications, and the web is still like a patchwork of libraries. There's no great way of bringing things together, and there's essentially like a new web framework every 2 weeks. I'm working on one, so there's plenty of those to go around. But the basics of HTML that we'll cover today have been around for a while. Okay, so HTML, we will be using exclusively HTML5 in this class. HTML up to 4 used to be an XML-based standard. It's still very similar to that, but HTML5 doesn't really follow strict XML specifications anymore. So what is HTML made up of? Like, so this here is these kind of tutorials that I'll be using. Can everybody read the text, even in the back? Yes? Good. And so this is interactive. I can actually change things here. and you will see after a while it immediately updates in this previews. So you can play with this while I'm talking and change things yourself. Okay, so HTML is made up of elements, and here we have this strong element, and strong essentially is kind of like means bold or like emphasize. I can also change this to B. Looks pretty much the same. I can change it to I, and it will change to that. So that's basically it. So we have HTML tags, an opening tag and a closing tag, and then the text in between the two of them. By the way, you can also, like, if you want to look at things in detail, you can open it in a. Well, this link is actually, or yeah, this link is broken. But generally, you can simply click on and open up a new page. Okay, so you can also nest HTML elements. So what you will build is essentially a tree, a structured document. So this starts with strong, and then we have like an underline in here. So this is strong, this is an underline, and I can also do like italic in here. So this is all formatting right now. Oh, closing tag. This is all formatting. So you see, it's underlined, it's italic, and so we have 3 levels of nesting. Top level is strong, second level is underlined, third level is italic. What makes the web interesting is, of course, links. And in this case, like, this is the A tag, but the point of this here is really that to show you there's the tags, and the tags can have attributes. The attributes can, in this case, be a reference, but it can also be a class, a specification, an ID specification, or something attribute specific. So href is the hyperref, is tag specific to A, and so we create this link to the Google main page. Okay, so the A element is the anchor, and it used to be used for anchoring within the page. It's nowadays mainly used for links, of course. And then the other attributes that we'll be using a lot is ID, class, and also style. And these, like, I'll be talking later about them, but they essentially help us identify elements in the DOM. Up to now, we have used elements that closed themselves, that didn't close themselves, but that had a closing element. So we had the beginning of an element and the end of an element. There are certain elements that are self-closing. So this would be a self-closing example, and this is exactly equivalent to this, but there is no text in between them. And so, like, a common example for that would be the break tag. So we can break a line in a paragraph for self-closing BRs, and that's what that looks like here, a self-closing BR tag. And so there's a couple of other, I'm not going to go through all the elements, I assume you guys know that, but there's like headers, there's lists, ordered lists with list elements, unordered list, and you can build tables, and so on. Then you can structure your HTML with essentially div or span tags that you can use to give, like, to do some logical containers, more or less. So a div or like div or span, they do something, but mainly they're used for, like, making semantic blocks. And so you will then be referring to these divs later. And then you can also do forms. You will do some forms even for your second homework already, where we have buttons and where fields and so on. So there's classical HTML form things. Like here's an input, as a text input area. We set a default text value. And then here we have a text area, and we can also specify what is in the text area, and then we have a submit button. And we'll go into, like, here are these examples, the table, then divs. You can see that basically divs don't do anything visible here. And then we have text, like the text field here, and the larger text field here. And submit button. Okay, so everything pretty simple. So a HTML page has some necessary boilerplate. So there's a couple of tags that are considered to be document metadata. And among them is HTML, the global container, the header, which defines essentially, like, a web page is not only what you show within this window, but there's also, like, other stuff that go into the web page. For example, the title that you can see here in the tab, for example. And then you can also do things like style, embedding style sheets, or like referencing style sheets, as you can see that here. So the link is for referencing or external documents. We'll do this quite a bit. And so here you can see how this link looks like. It's link, and then what is the relationship type, what is the type of the document that you're expecting, and then where is it located. And this is like a relative link in this case. Sorry for reformatting something here. It should be like list based, not well. And then after the head, the body marks the content of the website. So everything after the body is what's supposed to be visible within the browser window. So here's like a minimal example that is HTML5 compatible. So you tell, like it's a doc type HTML, you have a header, you set the character encoding to UTF-8, you set a title, and then we have a body. And so like this is what it looks like. Let's see what it looks like here, works. Yes. So this is the website, that's everything that is there. And you can see that if I haven't set the title, it shows me the URL. If I set the title, no problem. Okay, so all of this should have been familiar to you guys. Just for completeness sake, I've repeated it. So an HTML can generate a DOM. And a DOM is the document object model that the browser actually uses to render. They are, however, not exactly the same. So we will, like most of this class, if you talk about techniques, we will be creating the DOM dynamically. So this HTML, what we've seen here, translates exactly one-to-one to the DOM. But if we manipulate the DOM dynamically via JavaScript, we can actually detach the HTML representation from the DOM. So it's important that to understand this difference between what is the DOM, what is the HTML. Last year this was an exam question, so it's not going to be this year, but these conceptual things is something that I might be asking. So let's look at the DOM. We can, like, you probably have seen this, but every browser, like HTML is not, like, it's not a compiled language, it's not a compiled markup. Also not so is JavaScript. So you can look at the source of every website in your browser. Like even like Google Forms or Google Documents, anything like that, you can look at the source. It's not going to be easy to read because like larger websites often compile stuff and obfuscate stuff. But here that's going to be very easy to read. So what we can do is we can click on View Developer and then View Source. This opens up the source, but more interestingly, you can say View Developer Tools. And so this, by the way, is Chrome. We will use Chrome as a reference for all of our homework grading and so on. So you don't have to use Chrome, but you should test with Chrome, at least at the end. And so each browser, like for Firefox or Safari, all of them have these developer tools. They look sometimes different, but they're all pretty powerful. So what you can see here is actually the DOM. So this looks exactly the same as our HTML. Let me see what I can zoom that. This looks exactly the same as our HTML, but that's because we haven't done anything fancy to it. So the DOM corresponds exactly to the HTML. But this is not necessarily the source code here. I can click on sources, and then I can actually look at the source code. So here we see the raw source code. So like this distinction between the DOM and the source is important. If you want to like look at your JavaScript that you're editing eventually, then you can go to the source window and, for example, set breakpoints and so on, and see and debug your code. And then here you see the output in the machine readable format. Of course, you see the output also up here, but it's important to understand what the relationship between them is. And so you can either do this with the View Developer Tools operation, but what's usually more useful is going on Inspect Element. And so this will actually scroll directly to the element in the DOM. So let's open up like some random visualization, or let's just go to some more complex website. And so if I click here on Inspect, I see the website, but I get this synchronized highlighting between between all of these elements. And so I can drill down and I can see, okay, here is this class, this article. I can also like say, okay, I want to see where is this element here. I click on inspect, and I immediately see the corresponding DOM element here. And that is really a great way for you to look at what your code is producing. Like you have this representation, and then you can dynamically switch here and see the output. And then here you can go back to your sources. Okay. Here's a link that if you are interested in this, there's a good overview of developer tools in Chrome. So that's the basic HTML introduction. Now we'll talk a little bit about making things pretty. Well, let me see for 1 second. Yeah, I've made some changes earlier that I didn't yet push to the website. What you see is going to be largely similar, there's just some minor difference. So it's actually like cascading style sheets and selectors is a better title, because what is really important for this class is not so much that you make things pretty and that you learn how to style the CSS, but that you know how to reference DOM elements, and that's where like this interplay between CSS selectors and styling and so on comes in. Okay, so a style sheet usually consists of a list of CSS rules that are inserted within the style element. They can also be inserted directly within a tag element, but you can do it inline in HTML, or you can do it in a separate file. So here is an example. We see it, we have the standard header, and within the header we have the style tag here. And this defines we have a background color for this element or for this class. So like here, we are referencing the element strong. So like this will match, the selector here will match to all of the elements of type strong. So you can see in the element, in the selector for the type strong, we've set background color to red and font size to 300%. So let's hope it stops jumping. If I increase this, what's going on here? Let me see. So, okay. We'll live with not the perfect version, I'll push this later. So if I change this, you see the changes immediately. What happens if I do change this to body? Any guesses?
Everything will be red.
Correct. So now it's matching a different element. And so we can then be a little bit more specific on, like we can do multiple of those selections, we can do them separately. So here we have two strongs in a row. And both of them are going to apply. So whatever matches, they apply. When you have conflicting styles, so if I use another background color here, the last one matches. But this can get tricky. So there's a little, like these rules can be complex if it's a little bit more complicated. So I would try to avoid these kinds of conflicts. Okay, in addition to directly referencing elements, that's not particularly useful in many cases, we can also select by classes. And so we can define these classes using this dot notation, we can match these classes using these dot notations, and within the element tags we can give each of those divs, for example here, a class. So we say this one is of class importance, this one is of class footnote, and this one is both important and a footnote. And so here we have defined what the style that is applied to important is. It's a bold font, and here we have defined what the style that's applied to footnote is. It's like a reduced font size. So like we have this important footnote. So you can see this is like larger text, smaller text in bold. And so, like, yeah, there's basically not much more to say about this. Similar to classes, so it's like classes are referenced with the dot notation, and IDs are very similar. They're referenced with the pound notation or hashtag notation. The difference between classes and IDs is that IDs are supposed to be unique in your DOM, so you should not have more than one instance of this ID selector in your DOM. And so what you can see here is it works exactly the same. First line, second line, important. We can use this here. You should not use multiple this like this. I can do the class, like I can here, I'm repeating important and footnote, but I'm not supposed to do this with IDs. And you can also use IDs to anchor, to direct the link to parts of your document. So if you look at any of those, at any website, let's search for something. So here we have an ID, Utah logo, so that means that I can simply do pound Utah logo. So, well, it's at the top, but anyways, you can jump to a section, for example, like this, what you used to do with anchors. Okay, so here I've used a couple of like text shadow. It's ridiculously ugly, but it basically works. Like this is really not pretty and not readable, but you can do these kinds of things. Okay, you can then use a combination of IDs and CSS also to create layouts of a page. So that's where IDs are usually pretty useful. So we have something like a sidebar. We define its width, its height, its, whether it's floating or it's fixed, and the background color. Then we have a main element that has a certain width, a certain height, then it's floating to the right, and the background color. And then we have a footer, which is green and has 100% width. And so this is what this looks like. So this is like a basic HTML layout element.
I have a question.
Sure.
In this particular instance, is there any reason you used IDs over classes?
Yes, because I'm not going to have more than one footer. So classes are, like if you have, for example, a list of students and you want to render, like you want to apply a style to all of them, so these students are of class student, and then when I reuse that, then I would use a class. In this case, it's simply like all of these elements are unique, so I'm using an ID.
Okay. Is there any downside? I mean, is there any reason not to use a class even though you're only going to have one?
Not strictly speaking, it's just like semantically. If you look at the CSS and you see a class selector, then you expect it to apply to multiple things. If you look into CSS, like these things are often very disjoint, right? Where you render something in CSS can be in a totally different file from where it's in the HTML. So it's simply, it's not like in terms of like the browser is going to render it the same, but the semantics of it are different, and so it's harder to read. It's like bad software engineering, essentially.
Thank you.
Okay, so where it gets a little bit more interesting is relationship selectors. So up to now we have only selected based on something unique like an element or a class or an ID, but we can also say select all of the instances where B is a direct child of P, like bold is a direct child of paragraph, and then set this to blue. So this is like here the child selector. Or we could say select everything that is nested where a B is nested within a div. So like then what happens here is, let's say I have a div, tag, then I have a span tag, and then I have a, let's say, bold tag. This is not going to match this tag. This is. So this essentially tells us we have like some kind of hierarchy, some kind of parent-child relationship, but this tells us it has to be the specific relationship. This has to be exactly the parent, no steps between. And so if I were to remove this, it will actually work. So we can see that P to B relationship is colored in blue, and the div to B is colored in green. Now let's look at this text here. We have P to B here, so this should be like bold text within the paragraph because this matches this child selector. And then we have this B alone that shouldn't match anything because P alone is not specified in the CSS. And then we have this div to span to B, this indirect relationship from the div to the B. And so we can see that like this matches. This matches to bold, but it's not highlighted in blue. So bold is not a style in this case, it's part of the markup. And here we have this grandparent relationship that is rendered in green.
So if you wrap all the text, the text within a div.
Mm-hmm. This one?
No,
Or if I did it globally, like this, then all of this would match, all the paragraphs in here. So this will match, all the bold ones should now be green. And so that's actually what
Is it
happens.
because the order of these tabs?
Yes. So if I change this order, it will be blue. But again, not something that you should rely on. Yeah, this paragraph says you shouldn't rely on this and it can be really hard to debug. So in larger projects, CSS is commonly defined in a separate file. And then in larger projects, there's even like dialects of CSS, like SAS and so on. But for the purpose of this class, we will be using CSS. You can either do it within the HTML files, but if you want to reuse across multiple files, it makes sense to reference an external style sheet. And so this is how you would do this, and this would be on the same path as the HTML file. You tell it it's a style sheet. We can also do CSS styles directly in line, like here. You can see this is blue, steel blue. This is generally not encouraged to do if you're writing HTML proper, but in JavaScript we will actually quite often automatically generate these attributes, and that is fine. So it doesn't mean that your DOM shouldn't have that, it just means that you shouldn't write it because it's not very reusable from a good software engineering point of view. Okay, any questions about selectors, CSS, HTML before we move on to SVG? Okay, so let's do the SVG. SVG, like who has experience with SVG? One person. Okay, good. There's a purpose for me. SVG is the scalable vector graphic, by the way.
Thank you.
There's also, like, you would create, or you can create SVG with Illustrator or with other drawing tools. SVG has really only been popular on the web since HTML5. And so before that, support was spotty. And the great thing about SVG is that it's a vector graphic, and so we can zoom arbitrarily, we can see arbitrary details of our graphics. It's not a pixel graphic. And so like there's two ways of doing like now in-browser graphics, or three ways actually. There's SVG, which is what we'll be using and what D3 interacts with. Then there's Canvas, which is like a pixel-based drawing approach. And then there's WebGL, which uses like the OpenGL language, the web version of it, to do 3D graphics. So if you see a browser game that is a 3D shooter, it's going to use WebGL. There is trade-offs between all of them. SVG is, let's say, the easiest to manipulate because you have these explicit representations of all the objects. However, it's the slowest. Canvas is faster, quite a bit faster, but you don't have these explicit representations. And WebGL is very fast and is hardware supported in many cases, but it is also like the hardest to write, the hardest to maintain, and there's not like this, WebGL isn't quite as like rock solid across platforms. So SVG and Canvas is going to work across all browsers nowadays. With WebGL, there are some problems depending on your graphics cards and so on. Okay, so like this is our first SVG, and you can see it's extremely boring. So there's nothing in here because it's just an SVG, an empty element with a width and a height. So I have defined that, but if I open this up in a new page, I can actually inspect it here. Then I see the SVG, and it is actually being like highlighted 400 by 200 here. So this is kind of our canvas where we'll be drawing on now. So if we draw beyond that, it won't be visible. There's a couple of very simple things that you can do, like basic objects, like a circle. That would be the circle command. You give it like an X position, a Y position, and the radius. And then I style it. And so this is like one of the bad things about SVG. Styling is different from HTML. It looks largely the same, and you can use selectors like in CSS, like in HTML. But then things like coloring fonts and font weights and positioning and so on are different. So if you look up something on the internet about some styling for SVG, make sure that you always look for proper SVG styling and not for HTML styling. So here is our pretty circle. We have like a red stroke, a yellow fill, and the stroke width defined with 5 pixels. And so I can now change the position of this. I can change the radius. Now it's bigger than the screen for the SVG element. So yeah, not much more to say about that. We can do ellipses, so we have an X, a Y position, and then an RX and an RY. So here we see an ellipse, we can change that to 100, and now we'll have a circle. We can change that to that, and it will be an ellipse in the other direction. Rectangles, similar, like X position, Y position, width and height. If we change the position, we'll move over. Yeah, also not super exciting. Lines work quite the same way. By the way, here's here you can see the different styles for styling them again. We can use the same selectors, the same style document, but there is no CSS lines. Well, this is a class in this case, but the stroke looks different in CSS. So like here we did it inline, and here it is done in the header of the document. So here are two lines, and then we can change the to blue, for example. Lines have X, Y, X2, and Y2 positions. So let's change this a bit, and now let's make it big. Okay. We can also render text within HTML. So labels, for example, are important. Text has simply the text tag. And then we can do more complex shapes, like this path element here. And so, like many of those things that D3 can do for you, well, there's like a lot of stuff that you can do with rectangles and circles along and lines. But for more complex stuff, it uses these paths. These paths are really, really terrible to write by hand. So we will still make you do it in the homework, but only for simple paths, for no splines and so on. So how these lines work, or this path work, is they have this D attribute, and then you provide this code. And so how you can think about this, M is move your pen to this position. So M 1010 means move your pen to position 1010. So like if I'm removing this, it starts at 0, 0. Like if I add this here to 20, it starts at 0, 20. Then draw a line from the current position to position 1510. 5010. Or now if I would change this, draw to position 5020. Something change? Yeah. So 5010, 5020. So it changes like from being parallel or horizontal to tilted. Then we have another line and another line here, and then we have this C, this like curve attribute. And these curve attributes, they are kind of nasty to use. I have also added these circles here to give you an idea. Like these curves are interpreted as splines. So you give them a couple of points and then you have different spline functions that you can apply to them. And so here this is positioned at 150 and 50, the first one, and then at 150, 10. Like this point here is 150, 50, this point here is 150, 10. And so that's how that curve is rendered. You see it goes towards this one and then up from here. And so if we change this from 150, 50 to 150, 100, it will look like this. And so just to understand what is going on, we can also do this here. And so it's now like narrower because it goes further towards the point. Yes?
So what does the first 150, 50 represent?
Which one?
After C.
This? This is the first point. So let's just try what happens. So, you can also draw another point here. So you can see that this is the point back here. So essentially it's just another point. I can also take it out and it will look a little more boring. Oh, actually, well, I have to specify 3 points. Okay, the good thing is, other than for the first homework, you will not have to do this manually. There is line generators in SVG that generate those paths dynamically for you. And so most of the code that uses these paths is actually generated because it's much easier to write logic that generates those paths than to actually write those paths yourselves. And so here, by the way, if you use any resources to learn more about this, I would always suggest that you use the Mozilla Developer Network, MDN, and never use this W3C website. This W3C looks very official, but it's actually not, and it contains a lot of outdated examples. And the Mozilla Developer Network is usually the best resource. And so here is an example of these various curve commands, and I'm not going to go into detail because it's not super relevant for us, but you can see there's like these Bezier curves, and we can also do arcs, and we can do unions, and so on, of all of these elements, and generate complex shapes. Yep?
So I have 2 questions.
Sure.
So the first question is, do we always assume that the origin, whenever they draw, is always at the very top corner?
Yes, for SVG.
Okay, and then the second question is, how do you know whether, when it draws, is it always going up or down? Because if you're specifying 2 values, 45, 45.
Well, it's this movement. Like you're moving relative to, like if you draw a line, you're moving relative to the last position. So if you have like 1 point, 0, 0, and then you start the line that goes to 50, 50, then it depends on where your previous point was. Did that answer your question?
I just don't know why. So if you go 0, 0, and then you go 0, 10,
Yep.
it'll go up or it'll go down. But if you do 0, 0, 20, it goes down. I would assume it goes higher with a higher slope. That makes
Oh, let's look at the example. Okay, so here I'm drawing a line, right? Well, this is not a path. Let's do a path. So let's start at 0, 0, and just look at lines. Remove all of that. So now we have, we start at 0, 0, so this is this point, and then it moves over 50 and goes down 20, okay? And then from there on out, it assumes like you draw a continuous line. I could also say here, now move 10, 10. And so this is what would happen then. So essentially, you're always stroking continuously, but you can say whether you want to like press and stroke by either using M or L. Is that clear? So yeah, if we replace this again with an L here, we can see that we get a curve. So M is essentially skip the line, but change the position of your current cursor, and L will be draw the line to the next position.
So I think this might answer your question to some point too, but essentially you're never giving negative values because you're defining the coordinate system.
Oh
of the
yes.
grid.
Oh sorry. That like it's always not relative but absolute.
Yeah.
If that was your question. Then.
Yeah, I didn't, yeah.
Okay.
You can do relative with
Yeah.
lowercase though, right?
Let's try.
Yeah,
Like,
you can.
okay. Yeah. Looks like. Thank you. I didn't know that. As I said, but like this is more of an exercise in understanding what is going on in the hood. Then like you're not going to draw this manually. Okay, what happens if we draw elements that occlude each other? So obviously the order plays a role. So we have 2 times the same thing. First we have an ellipse and then we have a rectangle. And the first thing is going to be rendered first. So the ellipse is going to be rendered first and then the rectangle is going to be rendered. And that's important for, like, of course for rendering, but also for selectors then eventually. And so here is the inverse. We start with the ellipse and then, or we start with the rectangle and have then the ellipse, and therefore the ellipse is on top. So what is really important about SVG is the ability to group. And so we're also going to be used this a lot. So in this example here, we have 4 different circles. And if we, what do you want to do here? We always have to subtract the y coordinate from the height of the SVG element if you want to use like a positioning from the bottom. But we can also simply, like here every element is essentially by itself. So we have like, they're not relative to each other, but we can also have like a G here, like a group that groups all of them. And then we can say translate this and scale this. And so we can flip it around essentially. Okay, let's see what happens here. Well, it's out of the screen. Let's translate it away. So, yeah. So here we see like the same 2 things now. Let me reload this now. Now we can globally move this stuff around. Moving it a bit to the side. So we don't have to change the individual attributes. They are only relative to each other. And also, we can so this essentially gives us a better coordinate system. Like if we go here now, we can, this is the way how you could change your coordinate system to start from the bottom, from the left bottom. So here's 0, 0. If you'd like to think of it this way, and it's very often helpful to do that by scaling it, by inverting the scale here, and by translating it over, you can actually draw from starting here 0, 0 instead of here 0, 0. And so these groups are important because they allow us to group semantically relevant things together, but they also allow us to do like a global styling or some global transformation. And so these translate, transform, scales, and so on is something that we'll be using a lot. You can do that, of course, like the problem of using this approach of changing this coordinate system is the text gets useless. So here is happens what if you do exactly the same thing with text, it's of course not readable anymore.
Can you do nested groups and then like scale it, like flip the text back?
You can,
Okay.
yeah. So you can do nested groups, and you could flip the text back, but that is a tricky because then your coordinate system changes, and yeah. So yeah, but yeah, you can try. So, yeah, translate. Yeah, well, you have to figure out exactly where that ends up.
Yeah.
So it should be somewhere. That's why it's nice to have. Well, you can open it here. So the text is actually, like you can see where it is. It's here to the left, and then you can try to bring it back in. So it gets nasty. And of course you can, like, if you have a great geometric understanding of what is going on, then, it's easy to do. Okay, so here's a link to the relationship between CSS and SVG styling. You should take a look at this eventually. Yep.
Just going back to paths a little bit, can you define a function, or are you sort of stuck with just the standard spline interpolations in between?
You mean your own interpolation function?
Can you define your own function between, other than manually entering the points as an output?
Well, yes and no. I'm not aware of how, like, that you can do it as SVG, but you can do it as JavaScript. So you can essentially generate, and that's very common in D3, for example, that we have different spline interpolation functions. So like D3 wouldn't let do SVG, the interpolation, but would set more control points, and then you can define how you position those control points, which function you want to use. So in SVG proper, anything should be in here, but I would guess no. Well, you have those two different versions, right? The curves, and you can specify the arcs, but I would guess that is probably it. Any other questions? This was basically the HTML SVG introduction. This is everything that you need to know for your homework, and now I would move on to like software version control. So who's used Git before for GitHub? Okay, yeah, quite a bit. I'm not offended if you know everything here, like this. I'm just going to talk about Git. I'm going to talk mainly about it for two reasons. A, I think it's important for any like software engineer, computer scientist to know what version control is, what different types of version control there are. It's just like a software engineering practice, and there my software engineering undergrad shines through. And B, we will be using, like you are supposed to use GitHub for your project. So you're supposed to collaborate via GitHub, then build a website that renders a visualization, work in it as a team, and then also use GitHub features like GitHub Pages to directly display it as a website on the web. So this will be like an integrated version control and hosting solution for you, and that's why I think it's important to Git. Until last year, I also did all the homework submissions via Git, but this year we will be using Canvas for that. So, why would you want to use version control? Well, it's like if you do some serious software engineering, you want to keep multiple copies and states of your files. So, if you have a product, you want to release it, you want to start developing it, but then maybe some important bug shines through, and you need to publish a hotfix. So you don't want to change everything back, or look at this other state of your software, change it there, and then manually change it in your current development branch. But what you want to do instead is you want to have a system that manages these versions and that allows you to merge and switch between those easily. So you want to be able to create alternative states of your project. Very important is also collaborating in teams. So that's something, like I know people that use Dropbox for their version control, and then simply say, okay, I'm just sharing my code with other people via Dropbox, but what happens if you both edit the same file, or if you make conflicting edits that change the state somewhere? It's unclear. Dropbox will do some conflict resolution. It might not throw stuff away, but it will not be smart on how to merge things, for example. It will not have, like, if you change in one file two things that are independent of each other, there's no reason why you couldn't merge it, but Dropbox will not do that for you. Or also email or whatever. And then saving is something like, I don't know how rigorous you are with your backups, but your computer can crash, can get lost, and so on. So if you work with a distributed version control system and push stuff to a server, it's also safe. And then you can share, and that's like an important part of, for example, academic and open source software development is I can make my code available to others, and I can actually not only like upload it to a website, but other people can go in and change things. And essentially in GitHub, this has become very common that somebody publishes code, and then somebody else contributes and sends that back to this person. This person reviews it and then decides, oh, this is great, I'll merge it back into my current state or throw it away. So who's used CVS or SVN? Okay, those are centralized version control systems, and they're kind of like, they used to be dominant. I would say that probably in an open source context, Git is not popular. In a commercial content, I would say that context there is still a couple of those around. So the idea of central repository version control is that you have clients that are being worked on, and then you have one big server that stores all the versions, everything that goes in. So you have like very light versioning on the client, and everything that is happened, like everything that happens is on the server. So this is like, it's a very simple model, like a standard client-server star-based model, but it is complex for larger community projects. So for example, who do you allow read access or write access to your repository? In a big organization, there's often like a couple of promotions into your job to be allowed to write directly to the main repository. And in an open source context, like you cannot simply allow everybody to write to your repository, right? You have to manage it somehow. And then how do you essentially apply changes that somebody outside your outside your teammate that you don't know? How do you trust that? So you need to review that code. So that's not easy to do with central repositories. There's distributed version control. And a distributed version control is like a distributed system, like a peer-to-peer system. Each of those nodes here has essentially, not completely, but essentially a full version of the history. So my Git installation on my computer is conceptually equal than GitHub's Git installation on their server. So there is no difference. It has the same capabilities as their version. Like there's no big difference between a server and a client. Okay. So there is in practice very often like one dedicated central repository, but that is a convention only. And so that, like in this case, it could be two servers. And Linux, for example, is completely developed distributively. Like there's different versions, and people prefer very often Linux torvalds branch, or repository, and pull from them. But there's many different servers that you could use for that you can contribute changes to, and that you can pull them from. So the great thing about this is when I clone, like if I go to GitHub and clone a repository, I can start essentially very easily my own version control on top of it. I can make my changes, commit them, make branches and so on, and I'm completely independent from the central instance. I can also put them to another server and keep working with this other server. And then eventually when I'm ready, I can reintegrate it and ask the original owner of the code to take a look at my stuff. Another advantage of distributed version control is that all of the, like working with branches and so on, once you have everything on your computer, it's super fast and easy to switch between them. You don't need an internet connection, although that is becoming increasingly irrelevant. And so what also happens in SVN and CVS is that people commit in large batches. So they work for a day, and before they go home, they commit to SVN. That's because with these commits, there's very often testing, integration, and so on happening. But it's actually much better if you commit every little feature that you develop. So I've worked on a project where I have committed 80 times in a day. And I commit it locally. I don't have to push it out to the server, but then all these changes are in history and they're easily isolated. So I can say, okay, I did something first, and if this semantic unit of changes is over, then I commit. I write a message, what I did, and then I start with something else. So it's very clean in terms of keeping control of what is going on. So there is this tiny caveat that committing and pushing is different in Git. So committing is essentially just committing to your local repository. If you commit in SVN, it goes out to the server. If you commit in Git, it changes your local repository but doesn't synchronize with the server. So you have to explicitly say, push my changes out to a server. And so we'll go through this now. So you have seen centralized CVS, SVN, Team Foundation Server, and so on. And in the distributed classes, Git and Mercurial. And so we will be using Git here. Git, literally in British English slang, means unpleasant person, and Linus Torvalds, who created Git, also calls it the stupid content tracker. And then I like this quote from him, like, I'm an egotistical bastard, and I name all my projects after myself. First Linux, now Git. So why are we using Git? It's popular, like roughly 50%, and I looked at the number up 2 years ago, of open source projects run Git now. It is truly distributed, it is very fast, everything is local, it is free, and it is also very safe against corruption. So like every commit produces like a long hash, and if that essentially guarantees the integrity of your repository. And then of course GitHub is like a popular platform. But Git and GitHub are two different things, right? Git is the underlying technology, the software, and GitHub is this application platform with an issue tracker and website hosting and so on that a private company has built. So you don't need to use GitHub to use Git. We'll be using both of them, but you could just, like in your team, you could also synchronize via your own peer-to-peer connections. You wouldn't need to use Git. Okay, so here is where I will start to do some live coding.
Real quick before we move on.
Sure.
So if Git's, when you commit, if it's storing all the changes locally,
Yep.
do you end up having multiple versions of everything saved on your computer, or is it just tracking edits?
It's tracking edits.
Okay.
Yeah. And it is restoring based on edits, yeah.
Okay.
So it's relative, it's not making copies all the time. Any other questions? Okay. So once you have installed Git, like on Mac, it's pretty easy to install with Homebrew. On Linux, there is like installation instructions that are linked from this website. Once you install Git, you should also configure it to have proper names. Okay. So that's important because we also want to see, like, when we look at your projects, for example, we want to see who did what. We will be able to see exactly who of your team members had made what change in the code when we look at your repositories. So, and then therefore, you should use here your real name and your official Utah email address if you use this for your project. Okay, so I assume everybody is familiar with like basic console operation. So I created a directory and I'm changing into this directory. So we can see there's nothing in here. And now we can initialize a Git repository. Can you guys read that? Or should I zoom in more? Better? Okay, so once we have done that, we can see if we just list the content here, there's still nothing here, but if you list all the hidden files, we can see that there is this .git directory. This .git directory is your repository, so this is where all the tracking goes on, where all the changes and the versions and the branches and the configuration and so on is stored. So let's look at the configuration files in here. So we have the head information, the config information. So the config information is what is interesting. So we can see that we have one branch, the core branch, and we have a couple of additional flags. So there's not much going on. Here is an example from a more interesting, from the website, the course website, the repository where the course website is hosted. So here we have three different branches. We have the core, we have the remote origin, that essentially tells us where is this stored to, what is the origin of this repository, and then we have the master branch. Well, there's actually not a branch, but these two are branches. And so let's create a file. Now I've created a file, demo. And you can see this text is in this file. Let's add it to version control. That was stupid. I created it in the subdirectory. Okay, now I've added it to version control. However, like this isn't really like, it's not yet in the repository. It tells us okay, there is a change to be committed, demo.txt. And if we commit this now, by the way, if like, well, let's do this. Then that worked fine. So we can see I added a file, and if you don't add this message flag here, this -m, then it will drop you into an editor. And to add this commit message, you always have to add a commit message, and you always should. And so that worked fine. Now let's make a change to this. So I'm appending something. Let's look at the file. So we have two lines. Hello world, are you still spinning? Now let's look at the status. We can see this one particular file is modified, and if we now commit it, didn't work because it's not staged for commit. So we have to add all the files that we change every time. So we have to git commit -m or -a -m every time. So now it is actually tracked in version control. And then we can also look at the details of what was going on with this repository. So we can see all of the changes that have been made here. And that's useful to see, like, if you have like a conflict, for example, and if you have resolved something, to see the history. In practice, it's often easier to just look at the GitHub log because it's more accessible, let's put it this way, and you can see differences easily. And this is the commit hash that I talked about. So this is the thing that essentially guarantees that the state, like if you know that this commit hash is, you can check with your Git repository that nobody has altered that state, so it's a safety feature. Okay, so branching is important if you really want to work with a larger project and you want to try something out. So I'm going to create a branch. And now let's look at which branches we have. We have two different branches, draft and master, and the star highlights which branch I'm on. So I'm on the master branch. And so to check out the branch, to switch to the branch, I can run git check out draft. Now Git will tell us it's switched to the branch draft. And let's see if there's any differences. Nope, it's an exact copy. So I'm going to edit something. And then you can see that it's now in there. And now commit. We've changed that. Okay, so this is now in the branch draft. So there is this really line here. If we check out master, we see there really isn't there, because we have switched between the two different branches, so we have two different versions of this file now. And if I start editing, here, so now I have two different versions of this file that are not compatible. So I can now git commit and so if I now want to reintegrate them, this is going to be trouble, because like if I had done that without making the change and without making the change in master, and then I told it simply to merge into the main master branch, we would just have seen the additional line pop up. But if I now say git branch draft, git merge draft, it says automatic merge failed. We have to fix the conflicts. And so we can open up demo. And we see, like here, this is the head version, and this is the draft version. So I could now simply delete this, save it, and then okay, so now we have resolved that problem. Okay, let me see, did I miss anything? Good, so that is the basic Git introduction. Now let's take a look at GitHub and what GitHub can do for you. So we can create a new repository here. You should have requested private repositories, but I'm going to make this public. So this is now an empty repository, there's nothing in here. Usually you should have a README and also a license and a git ignore file. Git ignore file tells Git which files to not commit ever, unless you force it. Let's see. Should have clicked this link. Okay, and so when we want to clone this repository, what we do is simply select this here, then run git clone this URL. Now I created a class demo, like you can see there's a class demo directory here. And it's empty, but we have a Git file, a Git directory, and in this Git directory there is the information on where that comes from. So here is this origin definition. So this is from this particular URL. And so now I can essentially push to this repository and I can synchronize between them. So let's add a now add this to the repository. So you can see now, I checked for the status after adding this and committing this. It says on branch master, your branch is based on origin master, but the upstream is gone. That's not great. Working directory clean. So now we can push. And if we've done that, we can see that this will show up here. Like here's the demo file now. So pretty straightforward. We can then also, like if we make changes here, like you can actually edit stuff directly on GitHub. And now pulling will move these changes to my local file. So here we have the integrated version of those two. Okay, what is really important also and nice is the issue tracker in GitHub. So you can go here and say create a new issue and say like typo. So this is now my issue number 1. I can add screenshots easily and so on. But what is also neat is that I can do something like I'm committing this now, and I'll say fixed issue number 1, text. And now when I push this, automatically close this issue. So you can, this is a good practice, like if you fix a problem, you should also say which problem you have fixed in the commit message, and then GitHub would automatically close it, and it will add a reference so you can actually look at what was the difference, what have I done in this particular file. So this is all good software engineering practice and stuff. Okay, so there is also graphical user interface clients. There's GitHub Desktop that you can download. Some people prefer to use that. I prefer the console personally, but it's perfectly fine to do that. And it's also integrated with IDEs. As far as IDEs goes, I'll be giving out WebStorm licenses. WebStorm is like a big JavaScript HTML IDE. And I would recommend that you use that. You can commit stuff directly out of WebStorm. Here is what you can do to get updates from the homeworks. So when we release homeworks, we hope that they're perfect, but sometimes it happens that there's a little mistake, some typo, or anything like that. So what we'll do is we will simply update the homeworks, and then you can clone this repository, take the homework out of there, and can also push this to your own repository. And so here is described how that goes. So like here, by doing this remote add and then your private repository, you can keep your homeworks also on GitHub while also being synced to our central repository. So if we make any changes, they will immediately, if you update from our server, they will immediately propagate to your changes locally. And that's not going to be an issue for homework 1 or so, but in homework 3 we will have, we'll provide quite a bit of skeleton. So if we change anything in the code, this is how you could easily get updates. If you want to do this, here is described how to work with that. You can also do this manually and download the homeworks manually. We will always announce if there's any changes for the homeworks. Okay, any questions about Git or GitHub? Good, so next time we will get into JavaScript. It's going to be a little bit more exciting. This was more of like a basic stuff today. But starting next week, we will also start working with visualizations. Great, thank you.
And then we'll start streaming things on the channel. So this will be the URL to the live streaming, whatever happens. So you go there and yeah. So this is in a lag, like this happens like